So in this video, we're going to introduce the concept of a phase shift. A phase shift is the horizontal shift of a sinusoidal curve. Very frequently, the beginning of a period is referred to as the phase of one of these sinusoidal curves. Just to give you a quick example, if we were to consider y equals the sine of x, we know what that tends to look like on its first full period, going from 0 to 2 pi. So we would see pi over 2 here, we would see pi here, 3 pi over 2 right here, and 2 pi down toward the end. Now, to give an example of a phase shift, consider shifting this to the left by pi over 2 units. A shift to the left is indicated by the addition of a quantity. So that means that we would be shifting our sine curve to the left by pi over 2 units. All of the other corresponding values of x would also get shifted over by pi over 2 units. So this sine curve would look like the following. So instead of starting at the origin, it would now start at negative pi over 2. However, you may notice that now at x equals 0, the value of the function is 1, then it goes down to the midline, then to a local minimum, then to the midline. Turns out that by using a phase shift, we were actually able to turn the sine function into the cosine function. Through the use of phase shifts, especially when it comes to graphs, we can find that there are lots of different ways that we can construct these sinusoidal curves. Now, with that in mind, the full workup of a sinusoidal curve with every single possible transformation that we can have associated with it. In the previous section, we referred to a times the sine of omega x plus b and a times the cosine of omega x plus b. To indicate that a horizontal shift of some sort has taken place, we use the Greek letter phi. The rule that I've heard is if you're inside a classroom setting, it's referred to as phi. If you're outside of a classroom setting, it's referred to as phi. Insert a generic joke about Jack and the Giant Beanstalk thing, phi, phi, fo, fum kind of deal, yeah, good stuff. Now, honestly, when it comes to graphing these things, not a whole lot is going to change. We're still going to take on the same approach. So one period is still going to go from 0 to 2 pi. The only difference is the angle that we're now dealing with is going to be omega x minus phi. What that means for us is when we solve for x, there are actually going to be 2 steps that are necessary. So we'll start referring to this as the phase shift as well as the frequency modulation. So PS for phase shift and FM for frequency modulation. First thing we would do is add that value of phi to all 3 parts. So add phi to the x values. Then the next step of algebra that we would do is divide through by omega. We would get the following. Phi over omega is less than or equal to x, which is less than or equal to phi over omega plus 2 pi over omega. What this lets us know, then divide by omega. So that means that this quantity right here would be known as the phase shift, because that is now where your period starts. Hopefully you recognize this guy from the previous section. That is 1 period. 2 pi over omega. So just as a quick example of how to find a phase shift, determine the phase shift of Let's do y equals 2 times the sine of 3x minus pi over 2. The phase shift is where the period is supposed to start, and a period starts when the angle is equal to 0, which is what we were demonstrating right back here. So if I take my 3x minus pi over 2, and I set it equal to 0, I am finding the phase shift associated with this. So a couple steps of algebra. We'll add pi over 2 to both sides. We get 3x is equal to pi over 2. Then we'll divide both sides by 3 or multiply by 1/3. Multiplying pi over 2 by 1/3 lets me know that x is going to be equal to pi over 6, and that represents the start of a period, therefore the phase shift of our sinusoidal curve.